Hi everyone, happy Halloween! So today we will talk about 5.2 and 5.3. So I have some handouts here. If you need a copy, feel free to pick one. Okay. So today is the homework set 2, due dates. So from section 3.5 to 4.7. So these are the topics gonna be on your exam too. When is your exam too? Friday from 12:20 to 1:50. Yes. So if you have class on Friday before before us, or you cannot come at 12:20, and you still want the 1.5-hour test time, please email me. Okay, I'm happy to schedule a makeup exam with you on Thursday. Okay, so right. So if you need to schedule makeup exam before Friday, send me email earlier. Okay, as soon as possible. And then have you started working on your practice exam? Yes? Okay, great. By the way, we have some 5.2 handouts. If you need a copy, feel free. Yeah. Yeah, today please submit your homework. Do it multiple times. You can increase your homework scores. And then Wednesday at 8 p.m. we will have a virtual review session. Okay, everybody? So go to Tab Live. We will go to come and bring your questions. You can ask me questions of your homework or the practice exams or any problem. Okay, so we can go over them. Alright, so review session is on the Wednesday, 8 p.m. Okay, any questions so far? So exam is on Friday from 12:20 to 1:50. Yes, right. So this is the 5.2 handouts. Okay. All right. So if you have questions on your homework or anything, yeah, please feel free to ask me. Let me check. Do you have any questions? Post here. No? Okay. Hi! We have some 5.2 handouts here. Okay. And now let's look at the quiz. So I have already graded the quiz. Okay, the first problem. Let's see. Okay. So the first problem, we solve equations involving exponential expression. Because we only have one exponential expression, then we isolate the exponential expression. Okay, so there are so many different ways to solve this problem. Okay, you can use many different ways to solve this problem. So how do we isolate it? We can subtract both sides by 13. 41 minus 13 is 28. And then see the left hand side, you still have a times 4 to the 5 minus 2x. And we want to isolate the exponential term. That's why both sides divided by 8. And 28 divided by 8, we have a common factor 4. So 28 is 7 times 4. 8 is 2 times 4. That's why we cancel the 4. We get 7 over 2. And then see, we're ready. We isolate the exponential term. Okay. Then in order to get rid of the 4, we can apply log 4 on both sides, or you can apply ln on both sides. My recommendation is apply ln on both sides. Okay? So here, because at the end, if you have log base 4, you still need to change to ln, right? Your calculator does not have log base 4. The calculator has ln or log, right? So apply ln on both sides. We get ln 4 to the 5 minus 2x equals ln of 7 over 2. And this exponent, because of the properties of ln, we can move it down in front. When you move it down in front, this is 5 minus 2x times ln of 4. Okay? Don't forget the parentheses. And then you can distribute, so we can distribute. We get 5 ln of 4 minus 2x times ln of 4 equals ln of 7 over 2. Right, everybody? And then you can move the 5 ln of 4 to the other side. I see some of you, instead of distributing it, some of you divide both sides by ln of 4. You can also do that. Probably that method is easier, right? Instead of distributing it, we can divide both sides by ln of 4. So there are so many different ways to solve equations, right? You just pick the way you think that's easier. And we can now subtract 5 on both sides. We get negative 2x is ln of 7 over 2 over ln of 4. Subtract 5. And then, how do we get rid of the negative 2? Divide both sides by negative 2. So you get x equals ln of 7 half over ln of 4 minus 5 and then divided by negative 2. So far so good, everybody? So this is the number 1 on your quiz. So I have some extra 5.2 handouts. If you need a copy, yeah, come and grab one. Right. Okay, so the answer is 2.048. Any questions on problem 1? All good? Okay, let me erase that. All right. Okay. And then problem number 2. Okay. So problem number 2. Here, this is subtraction. Okay, this is subtraction. Log, combine the subtraction into the division. So some of you have the mistake, combine them, get a product. So log combines sum into products. And it combines subtractions into division. Okay, so attendance. Okay. All right. So this is subtraction into division, and this is log base 3. So in order to derive that, both sides raised to the power of 3. So 3 to the log 3 cancel. We get 2x plus 5 over x minus 5 equals 3 cubed. 3 cubed is 27, not 9, okay? And clear the denominator. Both sides multiply by x minus 5. So multiply by x minus 5, cancel with the denominator. And then on the right hand side, multiply by x minus 5. And then we distribute. So 27x minus 27 times 5 is 135. We want to combine the x. See? It's better to move the x to the right because 27 is bigger than 2. So we subtract 2x on both sides. We get 25x. And we add 135 on both sides. So we get 140 equals 25x. So x equals 140 divided by 25. And 5 is a common factor. That's why we get 28 over 5, which is 5.6. Many many of you stop right here. Remember for log, because our domain is not all real numbers, for log, we need to check the domain. Okay? So check. Plot 5.6 into this log expression. You see? 2 times 5.6 plus 5. Okay. This number is positive, so okay. Second expression. Log 3, 5.6 minus 5. See? That's 0.6. It's still positive. So, okay. Okay? So, we gotta check our work. That's why many of you get 9.5 out of 10. Because you lose that point. 0.5 here. Alright. So, that is the solution. Any questions about the solution? Okay, let's look at our mistakes. So we learn from our mistakes. Don't be afraid of making mistakes. You know, sometimes I also make mistakes, right? So we're all human beings. It's okay. We learn from it, and then in the exam, try to avoid the mistakes. Okay, so here, log. Okay, we can do ln on both sides, or we can apply log on both sides. But here, log base 10 and 4, they don't cancel. So we have the log of 4 here. That's why the answer, we have log of 4. And yeah, so that's the mistake. So subtract 0.5. And here, forget to check your work, so 0.5. And here, please make sure you show all your work, because if I cannot tell why you get this answer from this stats, you don't earn the points. Make sure you show every step. And then here, this is 3 cubed. So 3 cubed is 27. And then we distribute, so 27x minus 135. So here the answer is minus 20, but then why do you get the next line is 28 over 5? So the work does not support your answer. Okay? So please make sure your work supports your answer. Otherwise, some points will be off. Okay, so the mistake is here and we distribute. Okay, and also check the work. Okay, and then here, log of 3.5. So not log times. So log base 4 of 3.5. So this 3.5 is inside the log function. This is not multiplication. So be careful. Don't put the multiplication sign here. This is not multiplication. It's log base 4 of 3.5. And if we use change of base formula, okay, log 4 3.5 is log 3.5 over log 4. Here, if we don't put a base, that means the base is 10. You can also use ln. Your calculator has log base 10 and ln. Okay, so that's the mistake. And here, subtraction, divide. No, don't multiply them. If this is the addition, then you multiply them. And if you multiply them, don't forget the parentheses. Okay? And so it should be divide. And you see, if it's divides, the problem is actually easier because you just get a linear equation. Well, if you multiply, you get a quadratic equation, then you need to use the quadratic formula to find the roots. So it's harder than the quiz problem. Okay, and then here the mistake is subtract 5 on both sides. So subtract 5. Okay. And then here, subtraction, divide. And 3 cubed is 27. And also check your work. Okay, and so many of you forget to check your work. So I print screen some of your work, and then I realized, oh, many of you have the same mistake. Then I didn't print screen the rest. But if you see 9.5 out of 10, probably you forget to check your work. And oh, this has no mistake. I just want to show you this is another way to solve your problem one. So there are so many different ways to solve your problem one. This is another method. Okay? And you can see, even though the expressions are different than our answer, okay? But if we plug into the calculator, we have the same answer. See, this is our where's the quiz? Yes. So this is the expression of our quiz, but now this one different expression. But when we plug into the calculator, the answer are the same actually. And yeah, forget to check your work. And here, what's x? Divided by 2 and equal to what number? So please continue to finish the problem. And here, okay, 8 and 4, we cannot combine them, okay? Because 8, the exponent is 1. 4, the exponent is 5 minus 2x. If those two numbers have different exponents, we cannot combine them. Okay, everybody? And even though we have the same exponents, so if we have a to the n times b to the n, when we combine them, we multiply them. We don't add them. Okay, so be careful. So I would say it's good to make a mistake book, and then so let's say this is a sheet of paper, right? Mistake book, we can put it into like 3 columns. The first column you write down the mistake, and the second column write down the correction. And the third column, write down the formula that you need in this problem. So this is the formula, okay? Yeah, so it's good to have the mistake book, and then we can learn from our mistakes. And right, and then continue to solve the problem. Here, law combines subtraction into division. So we cannot add them, okay? So yeah, please review 4.5, the properties of log, okay? We cannot add those inner functions. It's actually divide. We cannot add those inner parts. They're not equal. Okay. So please review your notes. Okay. And the students, this expression I actually checked in the calculator, and that is correct. So, but then I don't know why you put 0.984. So don't write this because our answer is 2.048. Okay, so please don't write this line. Okay, yeah. So be careful to check your work. Don't write something wrong. Okay, so yeah, don't write this. And then this is perfect. Yes. So this is another way you can solve the problem. See, different expressions, but it's correct. Okay. And then here. Oh, this is also another way. And change base. Yeah, log 2, 7. Change base formula. Log 2, 7 is log 7 over log 2. And then you plug into your calculator, you have the same answers. Okay, so therefore, if your base is not 2, change base formula. Okay, then you can plug into your calculator. All right. And here, yeah, plug into your calculator. What's that? And here, I put y because, yeah, how do you get from here to here? Okay, and how do you get from here to here? Please show all your work, okay? So I should be able to see what you're doing in each set, okay? And also check your work for part number 2. All right. Okay, and then here, yeah, log 4 here. Don't forget we have log 4. And then, yeah, this is correct, but maybe when you, so I hope everybody, do you have your calculator? No, yes? No? If you don't have a calculator, make sure you buy one. On Friday, we have exams, and you need to have your calculator. Everybody clear? Mm-hmm. So, yeah, I will ask you what's the exact answer, and then plug into your calculator and get a 3 decimal answer. All right. Yes. And subtraction. Combine, we get division. And, yeah, this is 3 cubed. Okay. All right. Okay, so that's it. The other mistake is just like missing the check the work for problem 2. Any questions? So I hope all of you can learn from the mistakes. And please make sure you understand every example we go over in class, also in your homework, and also in the practice exams. If you have questions, ask me. Okay? Ask me. Come to my office hours. Or if you cannot come to my office hours because of time conflicts, please email me so we can schedule a time to meet. Okay, everybody? So let's try our best. Okay. So, right. If you don't understand, ask. Okay? Ask. Okay, so that is our quiz. All right. Okay, so today let's continue and let's look at session 5.2 and 5.3. Okay, so please do your practice exam multiple times. Okay, do it one time and then use your solution to check your work. Write down the correction and make sure you remember the steps to solve each type of problem. And then you can also do it second time, the third time, and make sure you can remember the steps. Okay, everybody? Mm-hmm. Yeah, from the experience of last exam, we know the practice exam is very, very important. So I hope all of you can do the practice exam and then we learn from our mistakes and remember the steps so we can do well on the actual exam. Okay? All right, so 5.2 and 5.3. Trigonometry functions, the unit circle. So here we have the xy plane. So we have the x-axis, the y-axis, and let's say we have a ray, okay? It's from the origin 0, and so this picture, the point is in the second quadrant. So this is the first quadrant, second quadrant, and the third quadrant, the fourth quadrant, right? And this picture, the triangle is the point is in the second quadrant. Let me draw another one. So the point is in the first quadrant. Okay, so that's 0. Okay, so this is a right angle triangle. And this is theta. The distance from the origin to the point, this distance is r. Okay, and this point is x comma y. That means this horizontal distance is x, the vertical distance is y. So far so good, everybody? Okay, now how do we define the trig functions? So this is the angle theta. Y is the opposite. It's the opposite side. Yes, everybody? Y is the opposite side. So let's put down opposites. Y is the opposite. And x, see? X compared to this angle is the adjacent side, is the side adjacent to that angle. So x is the adjacent. And r, have you heard of that name? Hypotenuse, right, everybody? Have you heard of opposite, adjacent, and hypotenuse before? Okay, very good. And have you heard about the Pythagorean theorem? Yes. So we have x squared plus y squared equals, bless you, r squared, right? This is the Pythagorean theorem. Yes. Okay. Now, how do we define the six trig functions? So this is sine. Sine of the angle theta is defined to be the opposite over the hypotenuse. Okay, opposite, see, opposite to this angle is the y. Hypotenuse is the r. So that's why it's y over r. So far, so good, everybody? Sine theta, opposite over hypotenuse. And then cosine theta. Cosine theta is adjacent over hypotenuse. Okay, so adjacent over hypotenuse. Adjacent is x, hypotenuse is r. So that's why x over r. Okay, and then tangent theta. Any guess? Is the opposite over adjacent. Yes? And then cotangent theta. Cotangent theta is the, yeah, adjacent over opposite. Okay. And then secant theta is, yeah, hypotenuse over adjacent. Hypotenuse over adjacent. Oh, what can you see? This is r over x. Well, do you see cosine theta is x over r? So secant is the reciprocal of cosine, right, everybody? So we know that secant is the reciprocal of cosine theta. So therefore, secant theta is 1 over cosine theta. Oh, and do you see tangent theta? Opposite over adjacent. Cotangent theta, adjacent over opposite. Do you see the reciprocal of each other? So cotangent theta is 1 over tangent theta. Okay, last one. Cosecant theta is what? Yeah, hypotenuse over opposite. And this is the reciprocal of sine theta. Right, everybody? So we know cosecant theta is 1 over sine theta. So these are the 6 trig functions. You're gonna memorize your name. Very important. Okay. Okay, so those are the 6 trig functions. Now, let's learn the trig identities. Okay, so I have a diagram which can help you to memorize the trig identities. So this is how. The way, so the natural order when we pronounce the 6 trig functions, we say sine theta, cosine theta, tangent theta, cotangent theta, and secant theta, cosecant theta. Right, everybody? So this is the natural order we say we pronounce those 6 trig functions. So you follow the order and then put them in the hexagon, right? And then you put 1 in the middle. Okay, everybody? So now, reciprocal identities. Do you see there are 3 diagonals? in this hexagon, okay? And for the diagonal, the product of the two ends equals the middle one. Okay, everybody? So that's why, oh, sine times cosecant equals 1. So sine times cosecant equals 1. That's why cosecant is 1 over sine, and sine equals 1 over cosecant. Is that okay, everybody? There were 3 diagonals. The product of the two ends equals the middle one. And then this diagonal, what do we get? Tangent times cotangent equals 1. Right, everybody? So, oh, cotangent is 1 over tangent. So they are reciprocal of each other. How about this diagonal? We get secant times cosine equals 1. Right, everybody? So secant and cosine, they're reciprocal of each other. So this is the diagonal rule. Okay, so this hexagon is just a way to help you memorize the trig identities. Okay, so we have 3 diagonal formula. Okay, and keep in mind, tangent is sine theta over cosine. Why is that? Look at here. Tangent is y over x. If you use sine over cosine, okay? So let's write it down. If we use sine over cosine, sine is y over r, cosine is x over r, right, everybody? And remember, a over b over c over d is the same as we multiply by its reciprocal. The reciprocal of x over r is r over x. Now, do you see the r cancel? Yes? Do you see the r cancel? So we get y over x. Y over x is tangent theta. So tangent theta equals to sine theta over cosine theta. Yes? And remember, cotangent theta is the reciprocal of tangent theta. So therefore, cotangent theta is what? What's the reciprocal of this? Cosine over sine. Exactly. Okay, that's why we have the quotient identities. Tangent theta is sine over cosine. Cotangent theta is cosine over sine. By the way, all of these are trig functions, right? It's cosine of the angle. This is not multiplication. It's a function, right? It's of that angle, not multiplication. Be careful. All right, and we have Pythagorean identities. Do you see here we have 3 upside down triangles? Yeah, because why do I call it upside down triangle? Because usually when you draw a triangle, you draw like this. But these 3 triangles are upside down, right? So, what is the good thing about those upside down triangles? So it has the rule that it has the rule that the sum of the upper 2 ends point square equals the bottom end point square. So this is the rule, okay? Therefore, if you look at this top triangle, sine squared plus cosine squared equals 1 squared. Well, 1 squared is 1. See? Sine squared plus cosine squared equals 1. How about this triangle? Tangent squared plus 1 equals secant squared. Yes, everybody? How about this triangle? 1 plus cotangent squared equals cosecant squared. Yes, everybody? So this hexagon helps us to memorize all the trig identities. See everybody? If you forgot the trig identities, draw the hexagon. And remember the diagonals. We have three diagonals. The product of the two endpoints equals the middle one. And there are three upside down triangles. The sum of the two upper endpoint square equals the bottom endpoint square. Okay, everybody? So this way we can memorize the trig identities. Yes, today these things we just gotta memorize. So this diagram helps you to memorize it. Yes. Okay. Practice. What do we do with that? Okay. Let theta be an acute angle such that sine of theta equals 0.6. Find the values of cosine, tangent, and secant using the trigonometry identities. Okay, so let's see. Let's draw the picture. So we have, let's use purple, okay? All right, so we have theta. Theta is an acute angle. So this is the x-axis, this is the y-axis, this is 0, right? The origin. And then theta is an acute angle. Okay, so this is what the picture looked like. Remember, we always have the term, the initial side is the positive x direction. And then our angle, we rotate counterclockwise. Right, everybody? And in the first quadrant, our angle is from 0 to 90 degrees, and those are acute angles, right? And how about from 90 degree to 180 degree, we get obtuse angle. Yeah, obtuse angle and acute angles, right? Okay, so the problem say, let theta be an acute angle. That means our point is in the first quadrant. Yes, everybody? So we have sine theta equals 0.6. Okay, and then we want to find the remaining values. Okay, so we have sine, and we're looking for cosine. What's the trig identities that involve sine and cosine? What's the trig identity that involves sine and cosine? Sine and cosine. Which equation has sine and cosine in it? Yes, right? Sine squared plus cosine squared equals 1. Oh, then we use that formula. So we have that formula, okay? So part A, we know sine squared plus cosine squared. And by the way, we like to put the power is like the exponent of the sine. So this is how we put it. Okay? Yeah. So sine squared, this is the same as sine theta squared. We don't like to put, so you don't see something like this. Because this notation is so confusing. Do you mean the square is the angle or the square is the whole thing of sine? Right, everybody? That's why to avoid this confusion, we put the square just on top of the sine instead of theta. Okay? So, because this is confusing. Do we mean this or do we mean this? It's confused, right? That's why we don't use this notation at all. We put the square just on top of the sine, okay? And so this means it's sine theta and square. So sine squared plus cosine squared equals 1. And we know sine theta equals 0.6. So 0.6 squared plus cosine squared equals 1. And we want to solve for cosine, right? everybody? What's 0.6 squared? 0.36, right? So we have 0.36 plus cosine squared equals 1. How do we solve for cosine? Subtract 0.36. So cosine squared, what's 1 minus 0.36? 0.64. Yes, everybody? 1 minus 0.36 is 0.64. Yes, everybody? Okay. Then what is cosine theta? To get rid of the square, you apply square root. But do you remember when we apply square root, we get plus or minus square root? Yes, everybody? Plus or minus square root. What's square root of 0.64? Yeah, we get plus or minus 0.8. Okay. Now, acute angle. Acute angle. Do you see acute angle? Our so acute angle, our y. So our y is positive, and our x is also positive, and our r is also positive. Right, everybody? So acute angle. So theta is acute angle. Then we have the x and y, they are both positive. So cosine theta is what? Adjacent over hypotenuse. Right, everybody? Adjacent over hypotenuse. So adjacent is x over hypotenuse. That's why this is positive. So we only pick the positive 0.8. We do not pick the negative 0.8. So cosine theta is 0.8. If I tell you the theta is obtuse angle, then what do? You pick the negative 0.8. Is that clear, everybody? Because acute is in the first quadrant. Obtuse is in the second quadrant, right? Now, do you see this x? Do you see this x is negative? So our cosine theta will be negative if the angle is obtuse. Okay, everybody? Yes. All right. So we get the cosine theta. This is part A. Now we keep going. B. What's tangent theta? Which formula do we use? Tangent theta. Sine over cosine, right? Yes. So we know sine, we know cosine. So tangent theta is sine over cosine. What's sine? 0.6, right? What's cosine? 0.8. Okay, what's 0.6 over 0.8? What do you get? 0.75. Right, everybody? Or, okay, if you don't have calculator, what do? You know 0.6 and 0.8, we can multiply the numerator and denominator by a number at the same time, right? So we can multiply by 10 at the same time. Do you see we get 6 over 8? And 6 over 8 has common factor 2. So therefore, this is 3 over 4. And you know 3 over 4 is 0.75? Mm-hmm. Okay, so if you don't have your calculator, you can do it like that. Okay, C. What's secant theta? What's secant theta? Which formula shall we use? Which formula is easier? Yeah, 1 over cosine. Okay? Do we use this one? No. Right, you don't want to solve this again. 1 over cosine is easier. Yeah, so 1 over cosine. And cosine is 0.8. What's that? Well, you see, we can multiply by 10 in the numerator and denominator. Then we get what? 10 over 8, yes? The common factor is 2, yes? So we get 5 over 4. So 1.25. Yes, everybody? So this is 1.25. You can use your calculator or you can simplify. So this is how we can solve the trig functions. Okay. Any questions about this problem? Are we all good? Yes. Mm-hmm. Okay. And then number 2, find the tangent theta given that cotangent theta is 4. What's the relation between tangent and cotangent? What's the relation between tangent and cotangent? Tangent and cotangent. Reciprocal! Right, everybody? Yeah, so tangent theta is the reciprocal of cotangent theta. And cotangent theta is 4. Therefore, we get 1 over 4. Yes, everybody? Okay. How about secant theta and cosine theta? What's the relation? They are also reciprocal. So secant theta is 1 over cosine theta. Reciprocal of that, okay, negative, we put the 2 downstairs, put the square root of 20 upstairs. But what is square root of 20? Yeah, square root of 4 times square root of 5. What is square root of 4? 2. Yeah, it's actually 2 root 5 over 2. Oh, what happened? 2 cancel. We get negative square root of 5. Oh. So far, so good, everybody? Mm-hmm. Okay. Okay. How about sine and cosecant? They are also reciprocal. Exactly. So the sine theta is 1 over cosecant theta. Reciprocal. So we get 5 over 12. Yes, everybody? Mm-hmm. Good. So the trait identity is very important. And in the exam, we don't have formula sheets, okay? So please practice memorize it. That's the hexagon. So once you draw the hexagon, then you can see the diagonals, right? You can see the upside down triangles. So hopefully you can use those to help you memorize the formula. Okay, simplify secant over tangent. Okay, so when you see simplifies, think about converts everything in terms of sine, cosine. Okay, because all the other trig functions can be converted in terms of sine, cosine. Okay, what's secant in terms of sine, cosine? 1 over cosine. Okay, so express in terms of sine and cosine, and then simplify. Okay, or cancel the terms. Okay. What's tangent? Sine over cosine. Yes, everybody? What can we cancel? Cosine theta. Yes. Aha. Do you see? Now we have 1 over sine theta. What's that? Cosecant theta. Yes. Very good. Okay. Yeah, so be familiar with the trig identities. Yes, express in terms of sine, cosine, and cancel, and then 1 over sine. That is cosecant. Yes. All right. How about 1 over cosine? 1 over cosine is secant, right, everybody? 1 over sine, cosecant. 1 over cosine, secant. Okay. Now, let's summarize. Okay, let me use this space to summarize here. Okay. Now we know this is the first quadrant. This is the second quadrant. This is the third, and this is the fourth. Okay? And in this quadrant, we know the R is always positive, right? And in this quadrant, you have your X is here, right? This is the X, and this is the Y. You see, X is positive, and Y is positive in your first quadrant. Yes, everybody? And how about in the second quadrant? Your X is negative. Your Y is positive. Right, everybody? How about in the third quadrant? Both are negative. Do you agree? How about in the fourth quadrant? X is positive, but Y is negative. Yes, everybody? Okay, so based on that, okay, depends on which point the quadrant the point is located. We can know all those 6 trig functions, which one is positive, which one is negative. Okay, let's write it down. The first quadrant, your sine. By the way, because x, y, they're both positive, so all the 6 trig functions are positive. Do you agree? So sine is positive, cosine positive, tangent positive, cotangent positive, secant positive, cosecant positive. Because your x, y are both positive, so all the 6 trig functions are positive. Okay, how about second quadrant? Let me use. How about green color? What's sine again? Is the y over r. Yes, everybody? Is your y positive or negative? Positive. So our r is always positive. Therefore, sine is positive. Yeah? How about cosine? Negative. Cosine is x over r. Because x is negative, so cosine is negative. Right, everybody? Tangent. Tangent is, okay. Now, after I know the sine and cosine, tangent is sine over cosine, right? So positive over negative is negative. And then cotangent. Cotangent is 1 over tangent. But tangent is negative, so cotangent is negative, right? How about secant? Secant is 1 over what? Cosine. And your cosine is negative. So secant is negative. Yes, everybody? How about cosecant? Cosecant is 1 over sine, and your sine is positive. Therefore, your cosecant is positive. Yes, everybody? Okay, the third quadrant. What's your sine? Sine is y over r. Your y is negative. Cosine. Negative. Tangent. Positive. Yes, very good. You see, negative over negative, you get positive. 2 negative give you positive, right? Cotangent is 1 over tangent, so that is positive. Secant is 1 over cosine, so that is cosecant is 1 over sine, so that is negative. Yes, everybody? Okay. Sorry, let me make it bigger. Okay, the fourth quadrant. Sine. Sine is y over r. So, negative. Yeah, the y is negative. Cosine. Positive. Tangent. Negative. Cotangent. Negative. Secant. Secant is 1 over cosine. So, positive. Cosecant. 1 over sine. So, negative. Okay. Now for the 4 quadrants. Depends on which quadrant the point is located. We know the 6 strict functions, whether it's positive or negative. Okay, very good. Now, if we know cosine t, by the way, the angle can be theta, or we can say x. The angle could be x, or the angle could be t. We can use any letter to represent the angle. So problem 6, it says that cosine t is 12 over 13, and t is in quadrant 4. See, right here. Find the values of the other 5 trig functions. So cosine is related to what? Look at the trig identities. It's related to sine, right, everybody? So if you know cosine, then we want to find the sine first. Okay. So, all right. So one way is to use similar method like this. We use sine squared plus cosine squared equals to 1. And then now we're talking cosine theta is 12 over what? 13. And then you solve for sine theta. So this is one way. Is that okay, everybody? Now I'm going to teach you another way. So you can think of this is method 1. Okay. And let me teach you method 2. Okay, so we know cosine t is x over r. Yes, everybody? And that equals 12 over 13. Now you can let x be 12. Bless you. And let r be 13. Is that okay, everybody? So method 2. By the way, your r is always positive. So if you have a minus sign here, what do? You let x to be negative 12 and you let r be 13. Okay, everybody? Awesome. So, and then because we have the Pythagorean theorem, yeah, x squared plus y squared equals r squared, right? Then x squared. So 12 squared plus y squared is r. R is 13 squared. Right? Okay, what's 12 squared? 144. What's 13 squared? 169. What's y squared? 169 minus 144 is it 25? So y is what? Plus or minus square root of 25, which is plus or minus 5. Yes. Quadrants 4. Okay, the point is in quadrant 4. So the y has to be negative. Aha. Yes, y has to be negative. Okay, boom. Sine t. What's sine t? Y over r, yeah? Y is negative 5. What's r? 13. Okay. Tangent is what? Y over x. Y is negative 5. X is 12. Cotangent is reciprocal of tangent, right? So reciprocal, negative 12 over 5. What's secant? Reciprocal of cosine, right? Yeah, cosine. So that is 13 over 12. And cosecant, reciprocal of sine. So that is negative 13 over 5. So this is the second method. Okay, you kind of let x be that number, let r be that number, and then you find the y and figure out which quadrant it lies in, and then you can find the subtract functions. Which method do you prefer? Method 1 or method 2? So this is method 1 and that's method 2. So you can use any method you like. Okay, so have a nice day. Happy Halloween. Go. Here, yeah, sure.